Welcome to this lecture. So in this video, I will discuss Laplace transform of unit impulse signal. The unit impulse signal is shown in this figure. So this x-axis t and on y-axis it is delta of t represents impulse signal. So impulse signal is exist only on at t is equal to 0 and on all other times its value is 0. The same thing we can express mathematically as delta of t, so impulse function, its amplitude is 1 at t is equal to 0 and its value is 0 when t is not equals to 0. Now in this case our x of t signal is delta of t. Now we'll write the formula for Laplace transform of x of t. So Laplace transform of x of t equals to integral over minus infinity to infinity x of t e power minus st dt. So now our x of t is delta of t impulse function. We replace x of t with the given signal. So integral over minus infinity to infinity delta of t e power minus st dt. So that equals to integral over minus infinity to infinity. Now I just write this delta of t as t minus 0 into e power minus st dt. Now this expression look like the shifting of impulse function. So we recall the important property of impulse signal is shifting property. So this shifting property says that if integral over minus infinity to infinity, so delta of t minus t naught into x of t dt equals to, we can write x of t naught. So whatever the value shifted, so that is written as a function of s, so that becomes x of t naught. So here, so this is delta of t minus t naught. In the place of t naught we have 0, so that is written as e power minus s of 0. So that equals to e power minus s of 0. So that equals to e power 0 and its value becomes 1. So Laplace transform of delta of t equals to 1. So this can also be write in the notation as delta of t 1. So this is the notation of Laplace transform for impulse signal. Now we write the ROC for the impulse function. So here the Laplace transform of impulse signal is unity. So we can call it is a finite value. Is a finite value for all s. Therefore, the ROC is exist on entire s plane. So now we'll draw the ROC. So this is s plane. So sigma is on x-axis and j omega is on y-axis. Now the ROC for this impulse signal is exist on entire s plane. So that we draw, so on entire s plane from negative axis to positive axis of s plane. So this indicates the ROC of impulse signal. Now the second one, so we'll see Laplace transform of unit step signal. So unit step signal has amplitude 1 on positive real axis and its value is 0 on negative real axis. So this signal is a causal signal which exists only on the positive real axis. So this signal mathematically expressed as u of t equals to 1 for t greater than or equal to 0 and its value is 0 for t less than 0. Now we'll try to find the Laplace transform for this function. So first we write the Laplace transform of x of t equals to integral over minus infinity to infinity x of t e power minus st dt. Now the signal x of t is given as u of t, so we can replace this x of t with u of t into e power minus st dt. So this integral is over the limits minus infinity to infinity. So for our convenience, so we divide this limits from minus infinity to 0 and we write the function u of t e power minus st dt plus integral over 0 to infinity u of t e power minus st dt. Now the first integration gives minus infinity to 0, second integration so it gives 0 to infinity, which covers the limit from minus infinity to infinity. So as per the definition of unit step signal, it exists only on positive axis, that is 0 to infinity, on negative axis for t less than 0, so its value is 0. So first in the first limit, so u of t becomes 0 and in the second limit u of t value is 1. So now the first term becomes 0 and the second term is integral over 0 to infinity e power minus st dt. So now we integrate this function e power minus st, so that gives e power minus st by minus s over the limits 0 to infinity. Now we recall the basic integral formula, integral of e power minus at dt gives e power minus at by minus a. So this formula is using here to integrate the function integral of e power minus st. Now apply the limits, so it gives e power minus infinity minus lower limit e power 0 divided by minus s. So that equals to e power minus infinity value is 0, 0 minus 1 divided by minus s. So that equals to 1 by s. So now we write the Laplace transform of u of t equals to 1 by s. So in other notation, so we can also write it as u of t, so double arrow, the 1 by s. So this is the Laplace transform of unit step signal. Now coming to the ROC for this function, so we write from this integral function. So observe this, so e power minus st dt integral over 0 to infinity. So this function is converges if s value is greater than 0. So only for s value greater than 0, so this function will be exponentially decaying function. So s greater than 0, s in the s means real part of s, so that should be greater than 0. Real part of s indicates that sigma is greater than 0. Now this will indicate in the s plane So sigma is on x-axis and j omega is on y-axis. Now this is origin, zero value. So now this ROC is exist for sigma greater than 0. So this is the portion where sigma value is greater than 0 and ROC is exist only on positive side of this S plane. So this portion we call it as RHS. So and an entire RHS, the ROC is exist for unit step signal. Thank you.